Yesterday we talked about graphing angles and radians. So when you're going around the unit circle in degrees, we have 0, 90, 180, 270, and then when we get back to the end, we're at 360. Now, if we were to mark that in radians, and radian is just a different unit of measure. So any measurement has more than one unit. For example, feet, inches, miles, that's distance. Minutes, hours, days, that's time. Angles have two different measurements. It can be in radians or it can be in degrees, okay? When we're talking about degrees, that's pretty simple because we already know that there's 360 degrees in a circle and we're counting by 90. But when we're talking about radians, okay, we're counting by 1/2. So essentially, so this is 1/2, 1, 1.5, 2. So any angle that is between 0 and 1/2 is going to fall in quadrant 1. And if it's between 1/2 and 1, it's going to fall in Q2. If it falls between 1 and 1.5, that is in Q3. And if it's between 1.5 and 2, it's in Q4. So we're going to practice graphing angles in radians. And the question that you're going to ask yourself is that fraction, ignoring the pi, because there's always going to be a pi in the numerator, is that fraction less than 1/2, more than 1/2? Is that fraction more than 1, less than 1? To figure out what quadrant it's going to fall in. The main thing I'm going to look for when you take your test, your quiz, is are you in the right quadrant? Okay, so let's take a minute and copy down these 3 or 4. I'm going to change the 4th one though. And we're going to graph these 4. I'm going to change this last one though. Oops. So we're going to graph all 4 of these angles in radians. We need to figure out which quadrant are we in. And then the last one we'll add is 5 pi over 4. Right, so go ahead and copy these down, and then we are going to figure out, we're going to do question B last. I'm going to do the positives first, and then we'll go back and do the negative. Yeah. So all negative, it doesn't matter if it's in degrees or radians, we're going to go clockwise. So show me with your fingers, where do you think pi over 4 is going to fall? Which quadrant? Okay, 1/2 and 1/4. So essentially, you have to figure out, is 1/4 less than 1/2 or more than 1/2? Because we're counting by a half. 1/4 of a dollar is 25 cents. Half of a dollar is 50 cents. So 1/4 is going to fall right here. It's going to fall in Q1. I am so sorry. I did not recognize. Yeah, sorry. Okay, so that will fall in the first quadrant. Okay, so we have that pi over 4. And if it's kind of difficult to figure out, you can always rewrite it because you have 1/2. Essentially, you're comparing 1/2 and 1/4. You're trying to figure out which one is higher. The only way to compare fractions is to have the same denominator. So if I multiply by 2, top and bottom, then that's going to be 2 over 4 and 1 over 4. 1/4 is less than, or 2/4 is greater than 1/4, which is how I know that it has to fall in quadrant 1. Okay, let's go ahead and do question C. So we have 4 over 5. So show me with your fingers what your guess is. What quadrant do you think 4/5 is going to fall in? 1, 2, 3, or 4? So 4/5, do you think it's more than 1/2 or less than 1/2? More? Who says it's more? It is. It is more than 1/2. Now, let's go ahead and talk about this. Just a reminder, because we haven't talked about fractions. An improper fraction is when the numerator is higher than your denominator. When that happens, then we know it's greater than 1. And we're going to be in quadrants 3 or 4. Okay, so I know automatically, because 5 is more than 4, that this is more than 1. So we just have to figure out if it's in quadrant 3 or 4. But A and C have a numerator that is less than the denominator. So I know it's in quadrants 1 or 2. So again, I need to figure out, I'm going to do it the long way, because I know fractions are kind of a struggle for people. If I have 4/5 and 1/2, again, the only way to compare it, the easiest way, is to have the same denominator. So I'm going to rewrite these with a common denominator. A reminder, you don't get to use a calculator. So if there is a calculator on your desk, you can put it under your desk, because you will not be allowed to use a calculator for the first chapter 6 and 7. So what I'm going to do is multiply this one by 2 and this one by 5. So that gives me 8 over 10 and 5 over 10. So which is higher? The 8. So because I see that, I know that this fraction is more than 1/2, which is going to push it in quadrant 2. So I'm going to start here, and it's going to lean me over in quadrant 2. Again, I don't care where you are in quadrant 2. I don't care if you draw it really close to the y-axis or really close to the x-axis. I just need to see you in the right quadrant. So this is in Q2. And this is in Q1. All right, 5 pi over 4. So now we know that we're higher than 1. So we're not in Q1 or in Q2. So we're either in Q3 or Q4. So we need to figure out, is this number more than 1/2? Because if it's more than 1.5, if 5 over 4 is more than 1.5, it's going to fall over here. But if it's less than 1.5, it's over here. All right, so again, let's just do it the old school way. We have 5 over 4 and 3 over 2. We need a common denominator. If I multiply it by 2, we can compare apples to apples. So I'm multiplying this one by 2, which gives me 6 over 4. So 5 over 4 is less than 6 over 4. So what does that mean? Which quadrant is it going to fall in? 3. And that would be your angle. And we're in Q3. Okay, same thing with these negatives, just like with degrees, except now we're going to swing clockwise. So I'm going to erase some of this. Okay, so I have 0 and negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Show me with your fingers. Where do you think negative pi over 3 is going to fall? What quadrant? Show me with your fingers which one you would put it in. Yep, because it's negative, we're in quadrant 4. Because 1/3 is less than 1/2. So we're going to put our ray in here. So this would be my initial side. And that's my terminal side. So this would be my angle right here. And we are in Q4. All right, let's do some more practice. I know that's kind of all over the place. It's kind of hard to be neat on these questions. So I'm going to give you 4 for you to do on your own. All right, so the first one is, I wrote them on the board, 2 pi over 3. And then I want you to graph 5 pi over 6. And negative 3 pi over 4. And negative 5 pi over 3. Okay. So take a few minutes and just try. Just try to graph them all so you can kind of quiz yourself if you're landing in the right quadrant. And then we'll go through it together in about 2 minutes. Okay, show me with your fingers what quadrant did you land in for 2 pi over 3. Hi. Thank you. Okay, so I'm sorry. But show me with your fingers what quadrant did you land in for 2 pi over 3. All right, I would agree. So if we were to compare the fractions 2/3 and 1/2, multiplying this first fraction by 2 and the second fraction by 3, that would give us 4/6 and 3/6. So that tells me that 2/3 is greater than 1/2, which is going to put us in quadrant 2. And again, as long as you land in quadrant 2, doesn't matter where you are, as long as you're in quadrant 2, you get full credit. All right, let's look at B, 5 pi over 6. Show me with your fingers. What quadrant did you land in for 5 pi over 6? All right, good, 2. So I have 5/6 compared to 1/2. So if I were to multiply that 1/2 by 3, that would be 5/6 and 3/6, which means that, again, we're greater than 1/2. Now, how do I know that this is less than 1, though? Yep, and then what did you say? Somebody else said something else. But yes, so we know that it's not an improper fraction. The numerator is smaller than the denominator, so I would agree. We're in Q2. So now for these last two, they're negative. So that means that we're labeling clockwise. So 0, -1/2, -1, -3.5, -2. Show me with your fingers, what quadrant did you land in for -3/4 pi, or 3 pi over 4? -3 pi over 4. 3, good job. So that is, again, that is less than 1 but more than 1/2, so that would put us in quadrant 3. All right, last one. What about -5 pi over 3? All right, you all doing really good. So 5/3, we just have to figure out, is 5/3 more than 1/2? And I know I'm writing blue on blue, so let me do this in black so you can actually see what I'm writing. Is 5/3 more than 3/2? So again, you can always compare apples to apples by writing it with a common denominator. I would multiply this one by 2 and this one by 3. So that gives me 10/6 and 9/6. So that tells me, because 10/6 is more than 9/6, that is going to tip me over into quadrant 1. So I'm going all the way around to quadrant 1, and that would be my angle. Okay, so now let's talk about the next piece of 6.1, and that is converting. So I'll give you a minute to copy down this slide, and then we will go through it together. Oh yeah, we're gonna talk about that. So an angle of 400 degrees is the same as a 40-degree angle. You just subtract 360 and see where your remainder is. That's called a coterminal angle, and we're gonna talk about that tomorrow. Because you can go over, you don't have to stop at one revolution. You can keep going around. So. So this is where our multiplication facts are going to really help us a lot, because we have to do these again without a calculator. We're going to be multiplying and reducing fractions without a calculator. So for this first one, when the angle is already in degrees and I want to convert it to radians, I'm going to multiply it by pi over 180. When you multiply fractions, you go straight across, because this 50 is over 1. It has an invisible denominator. So we're going straight across, and that gives us 50 pi over 180 degrees. Now, if you gave me that on the test, you would get partial credit, but to get full credit, you need to reduce that fraction. So if we know, if you have a number that ends with 0, that means it can be divided by 10. So we can just drop those zeros, and that gives us 5 pi over 18. Can I go any further? Does 5 and 18 have a common factor? Nope, so that would be my final answer. All right, let's do the same thing for question B. We're multiplying it by pi over 180. Are y'all gonna be able to sit together?
Sorry.
Do I need to do a seating chart? I've never had to do one in pre-calc, but okay. I mean, I can. So I want you all to. So we know that numbers that end with 5 or 0 can be divided by what? By 5. So again, we may have to do some long division. Don't say it out loud, because I want everybody to practice. But I want you to take 5 into 75. Oh, I forgot. Yeah. And take 5 into 180. So take a minute. Somebody in my first period, they counted by 5 to see how many fingers you would have to take to get to 75. You can do it that way too. Yes, so Karma asked if we could divide by 3. You could. You could also do that too. We're going to have to divide this essentially twice. Wait, yeah.
No, I'm doing fingers. Hang on.
Yeah, do fingers.
It makes more sense.
I thought
to me
maybe
to
do it
for
for
fingers.
For 75.
Because if you take
Oh.
the 0 off the 180, I know 18, and then just add the 0 back on.
No, for 75.
Huh?
Yeah, you do it that.
What?
3,
Oh.
6, 9, 12,
Oh,
15,
25 over
18, which is 6, and then you add the 0 back on, which is 16. Right? That's not the same.
What kind of math? What kind of voodoo math you doing over there again? You said
So,
what?
If you divide it by 3, 75 divided by 3 is 25.
Okay.
And then you do the 180. But if you take off the 0, you add it back on at the end.
Well, why are we adding it back on if we took it off?
Because dividing 180 by 3 and 18 by 3 are...
That's
Yeah,
voodoo.
see? Same work, you're just adding the zeros back on. Big numbers are...
So I just wanted to figure out with this voodoo math, what would be your answer?
Give me a
Negative
second.
5
Negative 25 and 16.
Okay, so that actually might be good. Okay, that might be good. I don't know. Keep going.
I know numbers too big and scary.
Okay, how many times does 5 go in? I'm gonna do it the old school way that we learned back in 3rd grade, I guess. Okay, so 5 goes into 7 one time. That leaves you a remainder. You bring down the 2, carry down the 5. 5 goes into 25 5 times. So we know that 75 divided by 5 is 15. 15 pi. And now we're going to do the same thing with 180. So 5 can't go into 1. So now we say, well, how many times can 5 go into 18? 3 times. 3 times 15. 3 times 5, sorry, is 15. 30. 5 goes into 36 times. We don't have a remainder. Okay, so we're getting closer, but now we can go down again. Because this time we can divide it again. What factor can I divide into 15 and 36? 3. So do it again. Don't say your answer out loud, but you're going to divide it by 3. So Karma divided it by 3 first and then divided it by 5. Either way, you get the same answer. I just thought dividing it by 5 was easier, but you just get there. You get there the way you need to get there, but you will not get full credit unless it's fully reduced. This is taking a long time. I'm falling a little bit behind, but that's okay. That's okay. That's okay. All right, so when I divide, I think it's easier to divide this one by 3 without needing to do long division. So 15 divided by 3 is 5. 36 divided by 3 is 12, and this would be your final answer that I'm looking for question C. To get full credit, you would have to tell me 5 pi over 12. Yes. Oh, and I dropped the negative, so let me put that back. Can't drop the negative. So to get full credit, you would have to say negative 5 pi over 12. All right, let's do the same thing with 215. So 215, we're going to multiply that by pi over 180. So then that would be 215 pi over 180. So what I recognize is that numbers that end with 5 or 0 can be divided by 5. So we already know that 180 divided by 5 is 36. So we don't have to redo that math. So we have something pi over 36. So you need to take 5 into 215. Don't say it out loud. Give everybody a chance. Figure out what we have on top. All right, so 5 goes into 21 4 times. 5 times 4 is 20. Subtract that. Bring down the, subtract, 20 minus 21, you get 1. You bring down the 5. 5 goes into 15 3 times. So 43 over pi is your final answer. Okay, any questions about how to go from degrees to radians? So let's go the other way now. And we'll finish this out tomorrow. I just want to start it. Now let's go from radians to degrees. So instead of multiplying by pi over 180, now you're multiplying by, let me zoom in, 180 over pi. So we'll probably only get through the first 2 today. And we'll pick up here tomorrow. All right, so let's go ahead and do the first two together. So now I'm multiplying by 180 over pi. So what is going to cancel out? The pi. So let's cancel that out. So essentially what I have is I have 5 times 180 over 6. So there's two different ways we can do this, okay? One way would be to take 5 times 180 and then take that number and divide it by 6. But one thing I noticed is that it might be easier for us to do this division, because most of us know what 18 divided by 6 is. And remember, we don't have a calculator, so we know what 18 divided by 6 is. What is 18 divided by 6? So what do you think 180 divided by 6 is? 30. So what we can do is reduce these two numbers by 6, which is going to change that 6 to the 1 and 180 to a 3. So all we have left is 5 over 1 times 30 over 1. And 5 times 30 is 150. Because remember, we have to use other methods because we don't get to use a calculator. Sometimes it makes sense to divide before you multiply, and sometimes it's easier to multiply before you divide. Either way, you still get the same answer. All right, I just want you to take a couple minutes and try to do B by yourself, and then we'll work through it. And we'll end there. We'll pick up on C tomorrow. So this one is not quite as easy because 18 divided by 4, I know what it is, but you may not recognize what it is. So it might be easier for this one to do 3 times 18 and then take that number and divide it by 4. Either way, though, I want to make sure you understand there is not a wrong way to do this. You can multiply 3 times 18 first, or 3 times 180 first, or you can take 180 divided by 4 first. So two people can do it opposite ways and still get the same exact answer. I think the answer is 135.
Yeah.
Anybody get 135 yet? Keep working.
Yeah.
All right, so who multiplied 3 times 180 first? Who took 180 divided by 4 first? Okay. Well, I was about half and half. All right, I think I'm going to do 3 times 180. So if I take 180 times 3, so I have 0 times 3 is 0. 8 times 3 is 24. You put down the 4, carry the 2. 5. I don't even think they teach you how to multiply like this anymore. I think you all do it differently. But that's how I learned it a long time ago. I'm pretty sure my daughter, she used to do something like this. And I don't know what she used to do. She used to do something different. I don't know how to do that way. I'm teaching you the way I learned. And so then we're going to take the 4 and divide that into 540. So 4 goes into 5 one time. Bring down the 4. 4 goes into 14 3 times. 4 times 3 is 12. Bring down the 0. Oops. And 4 goes into 25 times. So that would give you 135 degrees. And that'll be your final answer. All right, copy down C and D. We're not going to do it yet, but just have it copied down in your notes so we can pick up there tomorrow.